So hey guys, welcome back, and today we are going to discuss a very interesting topic, and that is text generation using LSTM. So why we are using LSTM, why not, why RNN failed, and all these things. There has been a lot of theory behind it. So I have written an article on that. You can prefer to this link. I will drop the link in the description. You can read all the concept behind the working concept behind the LSTM and RN, why RN failed. We can even apply GRU as well. So we have talked about all the theory in this article, and I will drop the link in the description. You can definitely find it and you can read and you can go through it, right? Just in this video we are going to talk more on the coding part, so that the video will be shorter and it will be completely explained as well, so at the same time. So in this video we are going to use a very famous data set, and that is New York Time comments data set. Let me show you. So this is the data set which I have opened. This data set contains only the headlines and the comments on that, right? So you can if you just go in this link, and if you just go down, and you will see that all these comments here, and their dates as well. So whenever we will work on this data set, we need to concatenate all the comments of all the dates as well. So there are multiple ways to do that. We will discuss that in the coding part. And let me show you the dataset. And the dataset contains headline. Mainly we have to have the headlines only. There are many columns. We don't need article ID and all these things. We don't need that one. We only want headlines, and that's all, right? Because we are training a text generator model, and we only need to pass the text, right? So the concept behind the text generation is, let me show you. So the concept behind the text generation is where it gone. Okay, so suppose in the model, what we will do, in the model we will pass a text. Let's suppose that we had passed the four text, right? Four word, we have passed the four word. We need to predict the fifth one, right? And once when we got the fifth one, using 1 to 5th, we gonna predict the sixth one. And when we got the sixth word predicted, we will combine the output, and we will pass 1 to 7 word and combine, and we will now find the eighth predicted word. So the process will happen sequentially, and it will generate a sequence of word, and the whole process is called text generation. So the basic idea behind it is that we need to predict the next word, right? And when we perform the prediction of the next word sequentially, it becomes text generation, right? So that's the whole concept behind it. And one more important thing, I just want to tell you that RNN failed because it has so many problems: vanishing gradients, exploding gradients, and how LSTM solved it by using various gates. And it has input gate, forget gate, and output gates. So you can definitely go through this article, and just going through it and just taking it. Okay, so we have all things discussed. So now let's come to the coding part, and we will start from the scratch. So first of all, we have to import all the things, right? So we have imported some pandas library and then TensorFlow library. For now, just focus on the pandas library. That for first of all, we need that, right? So just to load the dataset, we need pandas data frame. So in order to do that, just we had to import this library, right? So we have imported it. So we have imported it, and now the main thing begins from here. So what we have to do is we have to import all the comments, and all the comments contains in a column, and that column name is let me show you. So this is the data, and if you just look at anyone, let me open one. if you just open it one and let me filter it out, and then we will see that what we have actually here. um, Let me show you. Remove the document type, byline, abstract, article. There are so many columns inside it, but we don't want that. Oh my god. Just one more time. I just want to perform this operation and apply. And now if I just scroll it here, uh, there is an column name, and that is called headline. If you see that, we can see here. um, Let me search it. So here we go. So this is headline, and we only want this one. So let me show you this column. So this is headline, and it contains a kind of text, right? It contains only text, and that's all. You can use any data frame containing text or comments or reviews, anything you can use. So there is no any obligation that you have to use only this dataset or anything. You can go with any dataset you have or you want to work with. It can be any text dataset like summary dataset or something else. You can use that. So what I'm going to do here, I'm going to just make a variable, just made a variable, and that is input. So whatever dataset I will be imported, it will be in this directory, as you can see. And then I made all headlines list, and that will contain every headlines after combining the whole dataset, because there are so many dates. So after combining all these, I will extract the only headlines and I will put in this list. So using for file name os list here, and I have done it. And if I just show you, you can also use there is a lib package named glob. You can also use that for performing this purpose, and then you have to write less code. But for now I'm not going to use any other libraries. So if I just run 10 records, you will see that we have something like this, right? So we have something like this. And now our purpose is that we need to clean this data set, because there are so many dot and all these things. We definitely need to change that. We have to remove that. So the process of removing these dots, commas, and this uh, punctuation, basically this is the process of removing punctuation. So we need to remove the punctuation, and to do that we can use this function which we have prepared. So what I'm going to do is I'm passing each and every word, and then each and every character, and if the character is in punctuation, we will filter that out. So if there is we are combining only those words which is not in string dot punctuation. So string dot punctuation is what? String dot punctuation is a character group where you can find all the punctuation, right? uh, Wait, punctuation. So you can see that there is all the punctuation. So we have done that, and after cleaning you can see that this is more cleaner now. It only contains its spaces and characters other than punctuations. Now, so as you saw here, that this is okay. So now we have to generate something like this. We have to generate like this. First we will start from the one word or two word, and then keep appending one by one word. So it will, this is the process of training our model. So right, so we have to generate n-grams. So first we will take 4 words, then 5 words, then 6th word, then 7 word, and the next word will be for y variable, and that will be label, right? So we are trying to do that. So we are going to use a tokenizer, and this comes from Keras. So we have already imported here. If you focus just right here, keras.preprocessing.text. So this is tokenizer, and what tokenizer does, it takes a sentence, let's say it takes a group of words, and it tokenize them. It break them on spaces and other rules. right? So what we are going to write here, we are going to write a function, and that will create our model like this. We want something like this. So what the purpose here is, we have to create the sequence of tokens sequentially using n-grams, right? So what we are going to do here, first, after tokenizing, we have fit on text, and we pass the whole data set we have, and the data set we have is a list and containing the headlines, and then total words. So we have taken the whole words, and that is total words. And by why we have just added one, because we just take one extra, right? So there is a convention, so that's why total word we take it as. And input sequence is other for line in corpus, tokenizer dot text to sequence. Now it will, this tokenizer text to sequence, what it does, it first, this tokenizer will take the words and then assign them some number, and then this fit on text, this method does that, it takes each and every unique word and assigns some numbers, and then when we call tokenizer dot text to sequence, it map all the words into some numbers, right? So and when we pass the line, so it takes headline one by one and converts them into number, right? And then what we are doing, we are again generating a function, we are generating a loop where we will start from one, it means it will first generate one word, and then it will keep appending it, and then we will return. For now, just let's see the output. um, we are going to get the output. Just for now, I lost my network, just let me check. So if you see that we have generated sequentially using n-gram, so this is the data which we have prepared for the text generation. What it will take, when we pass this, the model will try to predict this one, and when we will pass this, the model will try to predict this one. So we have done something like this, right? So we have done something like this, and now the next step is, if I just if you just notice that our data set has now become so big. It's true, actually. We just started with few numbers, like we, in the initial point, we had total length of our data set was, let me check, length all headlines, and we had 829. Now we have over 4500. So it has become so big, but no worries, we will try to use this on the training part. And now one more important thing, that we haven't prepared the y variable. This is the only x part, so we haven't prepared the y variable, and I will prepare that as well. So for now, what we are trying to do here, so whenever we train our model, any model in our deep learning ML, or whenever we work on NLP more precisely, what we does is we pad and make each and every data having the same length, and the process is called padding. So we pad, the ways of padding could be either pre or post. Pre means appending 0 in the beginning, and post means appending 0 at the end. And we also have to keep in mind that the ways of padding must be same for the prediction, for the training, otherwise it will cause error, right? It will cause training problem. So that's why. Now the problem is, we have converted this into number, so this is fine for training, but for now it's not fine, because we have to convert each and every rows into same length. So using that, we have to convert into padding. So what we are doing here, so first of all, we are trying to find the maximum sequence length, and taking that sequence length, we will pad others, and if they will be shorter, we will append zeros. Okay, so this is max sequence length we have found here. And then input sequence we are padding here, and max length equal to max sequence length. So we have passed, and every data for now, after padding, every data will have the same number of length, same length, just more precisely if I say. Now after padding, these data will have the same length. Now our goal is to find the y part. Okay, so if this data set is if the model takes this rows, right, if the model takes this rows, it will try to predict next word. So the next word will be here is 117, and if I pass this to, then the next word will be 72. If I pass this, the next word will be 72. So our goal is to predict the next word here, right? So to find the next word, what are we trying to do here? So we are taking the last word using list comprehension. So the input sequence, and using this we are taking the last word. Okay, we are taking the last word, and this one will return me the last one, and this one return this list will return me from beginning to the last one except the last one, till the last one, not the last one, in excluded last one, and this will return me the last one. So this is simple lift comprehension. So we are minus one means we are taking the last one, and here minus one after colon means minus one, the last one is excluded. So now we will have something like this. Let me show you. After taking the last one, we will have an array. Okay, we will have an array, and let me show you here. Now it will be more clear. You will have an array, and in the first row you will have 117, right? You will have 117, and now you will have 72, right? You will have 72, and in the next one you will have 73, right? But this will be the label which we will pass for y. This will be label, and the remaining one will be x part our, and this one will be the y part. But the problem arises that we have to find something in categorical column. Like suppose this is 117, this is 72, this is 73. Now we want a matrix where we can assign this 117 with 1 and 0. Why? Because we increase the number of columns and we reduces the values. It means our model will be more generalized. So this is good practice to pass to categorical column. To do that, we are importing from Keras utils. So if you don't know that, let me show you. First of all, let's generate it, and if you see the predictor, okay, hope you are getting my point. So this is the predictor. After padding, we have padded pre, so that's why all the zeros comes in the beginning. And if you see the labels, actually it is label or labels, actually it is label, this is the label actually. So now you see that we have only 0 and 1, and now we can assign every numbers. So this is why categorical. Now it's time to design our model. So the concept behind is that we have to design a model using LSTM layers, and LSTM layers returns hidden state, cell state, and all these things. So we can combine so many layers as well with a number of neurons. Okay, so we are going to create a model, and this is actually a sequential model. You can also go with functional APIs provided by Keras. You can use any of them, but for now let's go with simpler one, that is sequential. And we have created an input length, and that is the maximum number of length of a sequence, and that will be the dimension of x, which we will pass for training. Model.sequential we have initialized, and then we are adding in the sequential. The first one is embedding layer. This is the total words. So total number of unique words we have in our dataset. And then this is 10, means the output will be 10. After embedding, input length is input length. So input length here is the length of x, actually the y dimension of x, what I means to say that. And then we are adding the LSTM layer with 100 neurons and then some dropouts. What dropout does is it regularize the whole architecture, whole model, by deactivating some activation points. That's why. And then we are adding the dense layer, and dense layer, as you know, that this is the output layer. And the total words here, and if you see that we have passed the total words in our vocabulary. Suppose there is a catch that the total number of words which we have passed in our data, the generated word will contain in the same vocabulary. So generated word will not come from outside, it will be from the dataset. Okay, so if you have so many if you have a big vocabulary, the text generation will be much greater. So it depends, right? It depends on the dataset. So always prefer to go with a bigger dataset. And model.compile, so we are compiling things up, and then calling this function by passing the vocabulary size and then sequence length. Sequence length basically means that the length of a single x row, which we have talked about. And then the model fit. So let me just run this. And model.fit, this is the training step that gonna take some time, so I will prefer to pause this video. So I have run this training for 17 epochs, but you can actually taking up times, and that's why I stopped it. But you can train it more, up to 100 epochs, or you can fine tune. Even you can fine tune for better results. Now it's time for generating the text using the next word. So as of now, the model we have built is capable for predicting the next word, right? So now we are going to prepare a function that gonna take the model which are capable of predicting the next word, and that now will be capable of predicting this character, will be predicting the group of words, you can say that, right? So the number we will pass, the number, suppose I passed 5, so the next, so it will predict 5 next word. So the seed text is the initial text we want to pass. It could be one, it could be 2 words, it could be 3 words, I mean the starting word. And then next word is the word which we have predicted, and it will work in recursion like that, or you can use a loop. And then model is the variable we have to pass the trained model, and then maximum sequence length, and in this case it's 17. And now using a loop we are going to predict the next word, and the pass the next word, predicted next word, in input again. So we have passed a seed text. Seed text is means starting word, and then padding up to the same length which we have trained on, so using the padding. And then we predicted the next word. As of now we have predicted only word, right? We have predicted a single word. By doing all these steps we have predicted one word, right? So if this loop run for one time, this will be predicted this will predict one single word. Now this is our variable, this is we will add every predicted word inside it. And for word in index, so the prediction model dot predict classes will predict the class, it will not return a predicted word. We need to convert the predicted this predicted variable is a class number. right? The class number means which word come at which class. So this will be a number, and we need to map this class number to back to a word using this tokenizer class, tokenizer word index. So tokenizer word index is a dictionary, and that contains a word and their specified index, or you can say their class number. So we found that, and then we appended in the output word, you can see that. And now again we have to update the seed text. We need to add the next predicted word as input, as we did here. Suppose in the first step we predicted down, and in the second word we appended this down word into our training, and then we predicted. So this is the step which will keep going on, and this next word is the number of words we want to be predicted. And now I'm running this from test cases. So I just pass some seed word like India and Pakistan, and we want three words to be predicted, and the model we trained on, like we have to just pass the model name and then maximum sequence length. So if I just run this, so now you can see that it has generated few words. In this case we have passed three, so it has generated three words, you can count here. And we passed the president Trump, the press Trump. uh, it has generated some words, and so on. So if you go more words prediction, it will definitely make some mistakes, and if you go with some single words like one and two predictions, it will work fine. So we can also improve this whole um, task by adding more data. I think this is the most important thing which we can do for improving this. And then fine tune network architecture and fine tune the network parameter, so we can fine tune that. But I think adding more data is much better option. And using more LSTM layers, for here we have used a single one. As you see here, we have used a single one, but you can add more LSTM layer combined, and it will promise you a better result, right? So I think this is much better way to optimize this. And often it is also called as poetry generator, because you pass some poem and it automatically generate a poem. So this is how we perform text generation, poetry generation kind of things. So I hope that you understood things up very well. If not, you can comment me, comment box is open, and you can write whatever you want to ask me. And I will also drop this article in the description box. You can go and check it out, whatever I have written about, right? I have also provided the theory as well as the coding part as well, so if you don't understand, you can copy it from here. Okay, so thanks for watching this video, and have a nice day, whatever.